Hi everyone. This presentation is going to be about securing a web application, surprisingly, the business security versus the OWASP top 10. So I'm Jean-Baptiste Aviat. I'm CTO and co-founder at Screen. Prior Screen, I was a pen tester, worked on startups, Fortune 500 companies, and then I worked 5 years at Apple, doing reverse engineering on the Apple ecosystem, iOS, macOS, cryptography attacks, and importantly, helping developers write more secure codes. So this presentation won't be focusing on the OWASP top 10, right? That's the title, OWASP top 10 versus business threats. So we all know and we are all quite aware of the OWASP top 10. Here, I'd like to focus on the other side of threats that are targeting more specifically businesses. So let's take a step back and look at what applications looked like 20 years ago. You had almost no frameworks. Ruby on Rails was not here. You had no NPM, no PyPy, or a very early version of them. It was only the beginning. And on this, the developers were writing a lot of things themselves, right? Interfacing with the database themselves, with the external services, and a lot of things were written again and again by developers in each company. Obviously, it was on top of the business logic. That was the technical layer you needed to have your app working. Then, 2010s, all right, we now have Django, Ruby on Rails. Things are much better because the developers can focus on writing business logic code, all right? Everything that we wrote previously, interfacing with the database, with the file system, everything, is put into frameworks. The frameworks, they are shared across all companies, and so they benefit from the security of the masses of organizations using them, right? So all the single vulnerabilities you had in the custom code we were writing previously, now they are in the frameworks are shared, so everything is quite better in terms of security. And today, the huge monolith applications are gone. We have applications that are relying on many others to discuss and to fulfill a user request, right? You have microservices or other services, maybe third-party services that we use to fulfill requests, like generating a bill, authenticating a user, extracting data from a data lake. For all these kind of things, we do not rely on a single monolithic applications. So is your business logic, right? Each time you do something that is quite tight to your company, it goes across several applications to fulfill a user request. So what's an attack against business logic? It's performing an action like ordering a pizza or accessing confidential data, like the list of your orders on a sushi store, or a security action like changing your credit card on Uber Eats, for instance. I'm sorry, a lot of these examples are about food. I'm French, that's how it works. So this is business threats that are specific to you, to your business, all right? As Domino's Pizza, you won't have the same threats as you would as if you were Twilio or the FDA, for instance. So the protections against business threats, they cannot be generic. You don't have one for all. You need to have ones that are specific to your business logic. So let me ask you a question. Who in the room need to protect more than 10 applications? All right? More than 50 applications. More than 100 applications? 200 applications? Whoa, that's a lot. Okay. 500? Okay. So, 1,000? Okay. Tell me how much? Many, okay. That's not too many. Your point of view. All right. Who else had more than 1,000? just to get a couple of figures, yeah? What's your business, sir? Yeah, sorry? Financial services. All right, that's a lot of applications. All right, that's a lot. So indeed, companies have more and more applications, and you have people in the companies that are here to improve and move these applications forward, like squads that are pushing code every hour to improve these applications. You have new applications that are deployed maybe every day or every week. And each of these applications rely on another application to fulfill a business request. So the protection on this is not possible at the network level because we don't know what the application is doing. That's like plain HTTP. We cannot rely on other tools such as static analysis, for instance, dynamic testing. You have to understand the business logic in order to test for its security. So the solution is to decentralize the security inside each application. That's the closer to the business logic we can be. And each application embeds its own security logic. So if a user request performs several actions to fulfill something, some of these actions are sensitive, right? If we lie inside the application, we can react if these actions are abused. Very well. How can we do it in practice? You have the big picture. Right? We want to sit next to the code to get valuable information. So we need to collect events at runtime, the closest to the business logic. So we need to build our toolbox to fulfill this. So first, item in our toolbox, a function. That could be something extremely simple that will just take as argument the name of a business event. And this function will send this business event to something, all right? But we want this function to be used everywhere we do like sensitive business calls. In practice, it means that in all of your applications, we would like tune the source code and add this helper everywhere. Okay, so each time there is a sensitive action performed on all your applications, this action will trigger this helper that may record this information. Where do we record it? That's the second item in our toolbox, in an event stream. It will store everything that is sent by our helper across all applications. The third item in our toolbox is an event processing and analysis system. So that's an engine that allows to crunch the data in order to detect security anomalies. What's happening? Is it usual, unusual? I want to know. Last but not least, the fourth item in our toolbox is the response. All right? If we detect something, we want to send a response. Maybe it will be to block the attacker, to deny a given action. I don't know. But we want, once we detected something, to stop the attack. So if we put this in motion, it gives us the following overview, right? We have several items in our toolbox we want to put together. So I can start detecting, like if the rate of the call to a given function, like user token generation, is unusual, then I want to respond. I might log the user account and maybe send an alert, like I want to send a webhook. Same thing, if the count of the call to user impersonation is above, I don't know, 10 over the last minute, then same thing, I want to raise an exception, maybe block the IP in the reverse proxy, and call the pager. So, if you think of it, what I'm proposing about security, decentralizing security across all applications and getting closer to the business logic, is the same as what we did with performance. Who amongst you recognize this picture? No one ever used this tool? New Relic? So if you think of the state of performance like 20 years ago, how did we measure performance of a web application? We were lying in the reverse proxy, in the load balancer, and we were measuring like the full time used to process a page rendering. All right, this is 100 milliseconds, that's too much. And then how do you act on this? It's not easy. So tools that are lying inside the applications have been getting more and more popularity. That's tools such as New Relic or App Dynamics. And these tools, as they lie inside the application, they can tell you this database request took a lot of time. This external service is behaving much slower than usually. And so thanks to this visibility given by the fact that these things lie inside your application source code, we can get a lot of information about this. If you think of it, it's even one of the pillars of the emergence of DevOps, because thanks to tools like that, ops and developers have been able to work together in order to improve how the database behaves or how the application's code behaves to query the database. And application security is taking the same path, right? From outside at the border of the network to inside the application, the closer to the application runtime we can be. So how can we do this at scale? Tuning the source code of all of your applications is very good on the paper, but it's hard to do it at scale. Like who's working with developers that are doing 2 weeks sprint? Yeah, 2 weeks. It's a lot when attacks are minutes, maybe hours. It's not the same time scale here. So we don't know every place in our applications where the business logic lies, because we have plenty of applications, we have several teams. It's not possible to know everything by heart. And when you write code, a lot of time, 1 year after, well, you don't remember exactly what you wrote and how it used to work, right? So it's not trivial to change the way to remember how the applications behave, exactly. So on top of that, we push code all the time. We deploy applications several times a day. Even the whole organization goal or engineering team goal is to make the developers work faster, because that's how we make our company move faster, right? Someone I know is saying every company is a software company today. And that's true. Most of the companies you know that are big enough, they have their own developers team, right? And it's a challenge every time to have these developers move as fast as possible. So the application security teams cannot break this flow, right? The goal cannot be to slow down the developers by telling them, oh, I need you to push this new helper each time you call a sensitive business function. We know this won't work, because when we embed a new developer, he won't know that he needs to call this function, because sometimes we fix things in a rush and we don't do it. So this approach cannot work. It's impossible to do this by hand. The solution would be to automatically generate all of these events from the applications without involving the development teams. The solution to this is called dynamic instrumentation. So here is a program flow. You have all seen this, I guess, that's several functions calling each other. One of these functions is called authenticate. Authenticate is the function we want to track. It's sensitive. It's doing really something I want to track because it's a sensitive business function. So I don't want to change the application source code. How can I do this? Do you know any kind of software that is doing this? You have all used it. You have all installed it. That's the antivirus. When you install an antivirus on a machine, if you try to open a file, the antivirus will forbid you to open it if it's corrupted, right? So how does it work? You did not change the internal of your operating system to say, now I want to use the antivirus. The antivirus, all by itself, replaced like the Windows open or read function, like the syscall, right? And this function, when it's replaced by the antivirus open, allows each and every program to behave as usual, but each time the program tries to open a file, that's the antivirus code that is triggered. The antivirus can check the file if it has a virus or not. If the file is safe, the execution goes on. All right, that's exactly the same as this. Here, the authenticate function, we just fake it, replacing by our own, and each time anything in the program is calling authenticate, it will go through our own code. That's code instrumentation. But it's not dynamic. In order to make it dynamic, we need to have this not hard-coded, but dynamically fueled to the application. Like we could hook any function, 1, 2, 3, 4. Here, we would be able, by asking remotely to the program, please hook function 4 or 5 or 6, to have our own helper called each of this time. So using dynamic instrumentation, we can replace any function with our helper without impacting the developers. How does it work in practice? In Ruby, it's really simple, because this language is highly dynamic, it's reflective, you have a lot of built-ins that allow you to do so. So these 10 lines of code allow you to do dynamic instrumentation very easily in Ruby. You just call this function defined here, and it will replace the method you gave in argument and call instead the hook that you passed, okay? When the hook is called, then the original function is called, and that's it. We just copy the original function with a temporary name, and we rename our hook with the name of the original function. Some may think it's crappy, but it's one of the many things that make the Ruby language so dynamic and so flexible. If you try to do the same in Java, here it's not the same story, because you know Java, it's compiled to bytecode that is analyzed and run by the JVM. So if you do this, you need to act at the bytecode level. It's quite difficult to do with the standard library. You have many third-party libraries that allow you to do so. One good example is ByteBuddy. That's the logo on the top right. ByteBuddy is an amazing library that allows you to build instrumentation in this way. But still, it ends with bytecode manipulation and changing the way the JVM understands the compiled classes. So it's much more difficult in Java than in Ruby. But still doable, and if you think of it, that's a bit how you could do it for any language using like simple debugger and remotely attaching to the applications. So let's assume we have something like this for all of our applications. We are inside the application, so we can retrieve all the context we need. Like, is the user authenticated here? Okay, when I am tracking a specific call to a sensitive business function, I can have this information since I'm inside the application. I can get custom business information. If someone is ordering a pizza, I can get the pizza ID, I can get the store ID. But yes, probably it's all in my code at this point. I can also know the framework information. Is it Rails, Struts, Node.js, Express, whatever? And I'm in a web application. Web application calls, they are triggered by layer 7, by an HTTP request, incoming HTTP request, so I could get any item of this HTTP request. Also, I could know the previous service that was called if I'm in a microservice environment, and maybe all the spanning information if that's something you pass application to application. So the amount of thing we can have is quite unlimited. Now, that's very good, but if we want to do this at scale, we need to convince the developers to use such a library in their applications. In order to do this, we need to have perfect reliability, no performance hit. That's not something that is trivial. So how could we do this? A pattern that is quite used in agent software would be to say, okay, we have a thread that is the runner thread. We have a queue. And each time we process a user request, we do like the least possible treatment in the request flow. And so if we encounter a sensitive business function that is hooked with our helper. This helper will only push information in a queue. So that's very fast. And later, we can have our dedicated thread that is pulling the queue. And so that's up to the JVM or to the Ruby interpreter or whatever to allocate time to this thread when the application is not like bottlenecking on CPU, right? So our thread is called each time the VM decides there is time for it. And the thread can easily unqueue items from the queue and purge them in the event stream. That's how we could architect this for speed and reliability. So at scale, I'm getting fast. At scale, how does it work? We can imagine we have a single library that is pushed in each and every of the applications. A single library, obviously, I guess you don't have one only technology for all your applications, especially people with more than 1,000 applications. So you need to have one library per technology. This library could, each time the application starts, for instance, fetch the remote directives for instrumentation. Remember, we said dynamic instrumentation, we push the order from the outside. So we could store these orders as a JSON file on an external server. Each time an application starts, it fetches this file and is able to instrument whatever it needs. So each time you update your JSON file, we could imagine the application is polling for it every minute or every hour and is updating itself. So very dynamically, you can say, all right, now I want to hook this new function. You put this in the instrumentation.json file, and that's done. The applications are instrumenting this new function. So each time an instrumented function is called, an event is registered in our event stream. So based on this, we could analyze many things, like the volume of calls, the successive actions performed by a user, by an IP. We could detect unusual activity, the anomalies in volume and proportions, and obviously we could also check the logic flows. All right, if ordering a pizza needs to select a pizza first, then select a shop, then trigger the order and pay, that's like 4 actions. We know it, all right? If one of these actions is not called, that could be an indicator that something is going wrong. Once we have detected something, we want to respond. We want to deny access to sensitive functions, deny access to a whole service, set an account as read-only, lock a user account, maybe log the user out. That's all actions we can do that are quite easy to do since we are already in the code. So we could imagine that we have specific helpers in this library to help us perform like business responses. Of course, we could also do notifications like trigger a pager, fire a webhook, or create a Jira ticket, for instance. Quick question, is there anyone from Facebook in the room? That's better. So you know, 2 or 3 weeks ago, Facebook got 50 million accounts that have been leaked, right? And we learned last week, I think, that a lot of metadata have been stolen as well, right? So the hack was quite terrible. 3 things have made this hack possible. In all of these 3 things, none of them is from like the OWASP top 10. None of them is a generic technical vulnerability. They are all business logic issues that have been combined by the attacker. The first one was, so I don't have a Facebook account, you know, I'm a security guy, right? But without any Facebook account, I think I still understood the thing, but if you think I'm saying something wrong, just tell me. So when you post something on Facebook, there is a view as function. Okay, this view as function can allow you to check as your mother, for instance, that she will see the right things that you intend her to see when you post something. This function is supposed to be read-only because Facebook does not want you to push data on the behalf of your mother, right? First bug. This view as function was displaying an upload form that were allowing people to upload videos on the behalf of your mother. Second issue, this video uploader was generating tokens that could be used on the Facebook mobile API. Unusual, but yeah, that's a bug, all right. Third issue, the video uploader was generating token when used with the view as function that were not for you, but for my mother, your mother, if you are. So combining these three bugs allowed the users, or the attackers, in this case, to generate token working on the Facebook mobile API for any kind of user they managed to impersonate. So that's how 50 million tokens got stolen. So let's put ourselves in the Facebook security team, and let's wonder how they could have protected themselves against that using the toolbox we just defined. So view as and video uploader are most likely two user-facing services. An internal service would be the user token management, right? It's like the thing that is dealing with authentication at Facebook scale. The thing I would monitor if I had to protect this thing would be probably the view as function, because impersonating a user, even if it's supposed to be read-only, is something that is quite sensitive. Second thing, user token management. I think I would never have bothered to instrument the video uploader thing. You upload video, that's okay. So how can we solve it with all the toolbox we have now? So I record these two things. Impersonate a user and generate a user token. Then I want to define rules to allow detect vulnerability exploitation. Like if a user is calling the impersonation function too much, or maybe if a user is calling generate token too much. What is too much? That's a good question, but could be anomaly detection. You could use many algorithms to detect and to generate a too much function. Then I want to trigger the security responses to be applied. So if I was working in the Facebook security team and I had to write this, obviously I would not lock the user the day I deploy this, right? Probably I would have it run for a couple of weeks and see how it behaves, tagging the users for review. And if the thing seems to be working correctly, then I would then use these functions like lock the user and probably tag the user for review, because if we lock a user, we are a B2C company. We want to be sure that this user have been locked in a good way. Some tools that we could use to practically implement this. The data streaming engines, they are going mainstream nowadays. You all know Kafka, probably. You have the Google PubSub, AWS Kinesis. All of these allow you to build highly performance data stream engines to gather all these kind of events. Anomaly detection is the same. I won't say it's trivial, but it's doable, and it's not, you don't need like a PhD to do it, or at least not a PhD in machine learning. On AWS Kinesis, you have by default a lot of algorithms that allow you to build like random forest anomaly detection, and that are working on any decent set of data. And then if we sum it up, let's assume we are protecting the Facebook infrastructure, right? So we have an instrumentation.json file that is describing all the functions we want to hook. We have all of our infrastructure with many microservices that are all using the library I've defined previously. And each time this application starts, they fetch the instrumentation file, so they are hooking the functions we want them to monitor. Everything is pushed to the event stream, so in the case of this attack, we would see like 50 million calls on a very short period of time on this API. Everything is sent to the event stream, and we can process and analyze it to detect probably an anomaly, a peak, a huge peak in the usage of these things. And that's it, we can respond, log the user, trigger any kind of security response we want. This is illustrated on a quite simple open source project. Don't use it in production, please, but feel free to check it out. You have all the basics you might need to poke things and to try things out. Any questions? I'd be happy to answer, and I'll be around all day, so feel free to reach out to me for anything.
Any questions, guys?
These business logic examples you gave are actually quite technical. Do you know of any sort of work being done in the more functional or financial sort of business logic?
Yeah, so we protect, for instance, a lot of marketplaces, and also kind of marketplace, a lot of Bitcoin exchange. These are all highly targeted companies. And the one pattern that is often seen by the Bitcoin exchanges is like you just sign up and you do a lot of payments coming from other users. And that's a sign that something is going wrong. Other thing, very popular attack against Bitcoin exchanges is credential stuffing, right? So I gather a database of leaked passwords, and I'm gonna try against all of your users for a combination of password working. If I have one that is working, then I will do a Bitcoin transaction to my public key, okay? And so if I detect this in a network exchange, well, it's not really a vulnerability, it's like really a business logic issue. And by using a similar approach, it's quite easy to detect and to protect against that. For the marketplace, it's the same. You have a lot of like money laundering. People, like your marketplace, allow people to sell T-shirts and other people to buy T-shirts. If I want to launder money, I can just fake selling a lot of T-shirts and buying them on the other side. And that's a simple way to launder money. So all of this, yes, are other examples of things you could detect with business logic.
Any other?
So I was just wondering, you were talking about actually protecting the microservice architecture by providing sort of endpoint telemetry for all the microservices that exist in the stack. What differences would you say that provides in your particular implementation versus something like AppDynamics, or as you were mentioning, your other particular example that you were using before?
So AppDynamics or New Relic or things like this, you're right, they lie inside the code, but they are not built in a security-minded way, right? They don't allow you to capture events remotely at the scale of a company. Yeah, like New Relic Insights, for instance, yes, you can use it. You have to instrument each place of your code where you want to send business metrics, right? It's working well to build like business analytics, all right? The way it works, you have like the business team that is saying, oh, we really need these analytics. And so you have the developers that are fed with these specifications, and one sprint later, or n sprint later, depending on the power of the guys, then the thing is released. But it's working because these guys, they have a strong interest in the company's business. The security teams, usually it's a bit less priority. And if you want to do it at scale, it's not enough to do it with one application. You need to do it with all of your stack. So you need a different paradigm to work this. Like the business logic is one of the many things you have to deal with when you are an application security team.
The one thing I just would say is, for example, I get what you're saying is that maybe at scale, you wouldn't be able to monitor all those endpoints, or you wouldn't have telemetry on all those endpoints or something like that. But at the end of the day, I mean, in our particular case, we use AppDynamics quite extensively. And in a microservice architecture, mostly in the modern way of doing microservices at least, they're all just APIs. And AppDynamics just monitors those API endpoints. And you could add some telemetry on, for example, calls per minute on a particular endpoint, any endpoint in your stack. If that calls per minute metric spikes above a particular threshold, send out some sort of email or whatever the case may be, and there you go, you kind of know that someone's hitting that particular vulnerable endpoint. So what difference would you suggest that this implementation kind of provides against that?
Well, the endpoint is quite granular. Again, endpoint is like layer 7 HTTP. It's not a given function. So it means that each time one developer will change like the way the application is behaving, the endpoint will change, but the business logic that lies deep in the code might be unchanged, right?
I guess, but so just on your Facebook example, I don't mean to be argumentative here, by the way. Just with your Facebook example, if I say upload video is a particular function, that particular function will be tied to an endpoint, realistically. I mean, the modern way of designing software, I must say, coming from a developer mindset, the modern way of designing software is to make it as granular as possible. If I design an endpoint, there's not going to be much code behind that endpoint besides what it's designed to do. So if I say design an endpoint that's for upload video or view as you were saying in your example, if I monitor those two endpoints and I see that calls per minute goes up to 600,000, I know that there's something wrong in my application.
Yeah, but I agree. That's like the best practices in software development. Yeah, I think we are, first of all, not only defending applications that follow the best practices. That's one thing. And yeah, I agree. This might not work in any case. I'm not saying that this is like the solution to any kind of vulnerabilities here. Don't get me wrong. But I definitely agree that yes, in some cases you could have a mapping between function and endpoint. Yes, that's possible. And in this case, maybe. But still, if you want to build the whole toolbox with app dynamics, how would you like lock a user or trigger a security response? That's all things that need to lie deep in the code as well.
No, I agree. I mean, that's not stuff that comes out the box with app dynamics. Yeah, definitely.
That's a workaround,
Yeah.
but app dynamics is a great tool.
Any other questions, guys? Questions? Well, thank you very much.
Thank you very much.